There we go. Hello, today's presenter is Robert Knight. He's a senior building, sorry about that. He is a senior smart building consultant at AirUp, working in the Chicago office. So thank you, Robert. Take it away.
Thanks, Rebecca. You can hear me okay?
Yep, can you hear just fine.
Oh, thanks. Well, welcome everybody and happy St. Patrick's Day. Today, we're here to talk about the role of smart buildings and with a specific focus on how they can contribute to hitting some aggressive targets to reach net zero and beyond. And to begin, I'll tell you just a quick bit about myself. I don't do a lot of public presentations like this, but I consider myself to be a pretty good expert on smart building systems. I've been a system integrator. I've co-founded a software startup, and I've done an awful lot of building control systems design work in my career across all types of buildings, across all parts of the globe. And as Rebecca mentioned, I work as a senior smart buildings consultant at AirUp. I sit in their Chicago office. So a little bit of clickbait. We talked about net zero decarbonization and electrification as the cause for you gathering today to learn about how smart buildings can play a role in reaching these lofty targets. We're going to talk a bit about what those targets look like, but mostly the content today is going to focus on some of the current trends that are happening in the smart building space and how those different trends could affect or help to reach that net zero future as a piece of a larger solution that we in the building design space have to come up with. Before we talk about how smart buildings can help, we need to figure out what's the problem we're trying to solve. I think everybody who joined today is, as members of ASHRAE, well aware that the climate emergency is rolling towards us at an alarming speed, and we that work in buildings have to do our piece to try to help improve the situation for the planet. There are certainly a lot of other reasons why you may want features of a smart building in your portfolio, in your building, but one of the key things that a smart building can help to solve is energy waste and how to tune the delivery of services, utilities generally, to the building so that the building operates at peak efficiency while still satisfying its fundamental purpose for being. So just as a little bit of background, I'm sure everyone on the call has a sense of what these terms mean, but they sort of intersect quite a bit. At the middle of the Venn diagram would be the ideal, future state, but we take net zero to mean a building that doesn't consume more off the grid than it is able to put back. It's at break even, and so local renewable generation would be required for true net zero. There are definitions of net zero that allow you to purchase renewable power from a grid operator, and that's a sort of an exception to how we see net zero. We really believe it means local on-site generation. Electrification means to remove any gas burning appliances from the facility. If we can get rid of all gas boilers and replace with electric, if we can get rid of the gas range or the gas ovens in commercial cooking kitchens, now we can utilize those on-site renewables, the renewables that your grid operator is generating. We can employ battery storage to help reduce peaks and backfill dips. And then decarbonization is the effort to reduce the total energy spend and therefore the carbon emissions attributable to the operation of a building. When we can't reduce, we can at least try to shift to level it out some, and that can be useful more so in the future when the grid becomes more renewable. So the production of electricity by the grid operators will vary depending on the weather conditions on a particular day. So the ability to shift our energy spend around a bit within the building could be valuable. So there is a challenge in solving these big problems of trying to get a building to net zero or trying to remove all carbon emissions from the scope of how a building operates. And many of these, many of the big things that need to be done are big and expensive and are much more easily accomplished in new construction than in retrofit. So underlying everything is the program for a building, or its purpose for being. If a building exists to be a cold storage warehouse or to be a data center, there's little that we can do in the construction of the building to change the huge energy hogs of the equipment that it takes to operate that building. And if we remove those energy hogs, the building wouldn't serve its intended purpose. So the program underlines everything. And then above that sits the building's envelope and how it's sited on a piece of land. In a retrofit, it's usually impossible to do anything about the siting, and it can be very expensive and nearly impossible to make big changes to the envelope. It's very costly to fix a leaky facade or change all the glass single pane glazing to a triple pane insulated glazing system. It's difficult to backfill or infill excessive glazing with wall to improve the energy performance of the envelope. But the envelope drives the energy spend of the building with respect to heating and cooling quite significantly. A little more attainable, but still costly, are major equipment replacements. So replacing the chillers or the boilers in the building to get better heating performance, or maybe replacing all the kitchen equipment with new electrical efficient equipment. Perhaps it's a lighting retrofit that replaces old fluorescent with new LED and better modern lighting control systems. But up at the top of this is smart buildings. I would say that smart building features are the easiest, least costly item to add into an existing building as a retrofit. But with that, we have to understand that the opportunity to impact the energy spend is equally proportionally small, I would say. I tell people all the time that a smart building can't fix a leaky envelope. A smart building can't make a 20-year-old constant speed chiller work more efficiently. But we can, if we've got the underpinnings solved. Smart buildings can be a very valuable way to get that next 10% perhaps, or how do you squeeze more water out of the stone after you fixed your envelope and replaced your central plant? We can apply software, we can apply sensing technology, and we can work the magic there to make things a little bit like incrementally more efficient. And then we can use that technology to keep things running at peak efficiency over time. And I'll get into more of that in a bit. It's also useful to kind of have a look at where the opportunities lie to make buildings more efficient. This chart was from a DOE brochure, but it kind of shows you that of the energy spend in a typical commercial office building, 35% of it is driven by heating and 10 from cooling. So if you add in ventilation, the HVAC is more than 50% of a typical commercial office energy spend, and then another 25% comes from lighting. So these are the scopes that we in the mechanical, electrical, plumbing design space can directly impact. We often can't do much about the computers that the tenants choose to set up, or the servers in their IDF room. If they need a refrigerator for their cafe, we can't do much about that. But the 75% slice of commercial office buildings is something we can and should be trying to directly impact and make better. As we think about how to solve these huge intractable problems of climate change and then what we do with smart buildings, there are a couple of little details here that make doing the right thing more challenging. Probably number one is cost. That's my dollar sign on the right there. At the end of the day, the best intentioned building owner, developer, tenant always has an accountant who needs to balance the initial capital expense against the desire to do right by the earth and to reduce their energy spend. We also need to make sure that buildings that we work on going forward have to be resilient, because we all know that some degree of climate change is inevitable. It's happening already. So while we make buildings more efficient, we also need to keep them resilient to deal with what bit of climate change may actually occur beyond our control. And then the real fundamental thing that ASHRAE members know well is that the innate conflict between trying to balance the efficiency of a building with the comfort we deliver to its occupants. Eliminating simultaneous heating and cooling is a simple example of this. We put a deadband in between the temperature that will heat a space to and the temperature will cool a space to make it more efficient. But in that deadband, we sacrifice a bit of occupant comfort sometimes. And striking the right balance will depend on each end user and how much they're willing to tolerate lessened comfort in the interest of efficiency. So with that sort of backdrop, the problems that we need to solve, let's talk about what Rob means when he says a smart building. I'll begin by just sort of backdrop to all of this. Right now, we like to talk about that we're in the fourth industrial revolution, right? We're all aware that steam revolution, electricity, and then in the 70s, 80s, 90s, computing became the new industrial revolution. And we think that now we're in a fourth stage where we can apply intelligence to the computing to better, in our particular case, to manage the energy spend. So what is a smart building? A smart building means a different thing to every single person that'll talk about it. It's a collection of technology enabled features that together create some sort of outcomes. That's a generic way of saying it. So here on the left, I've shown a few of the possible features that could get collected together. But what do I mean by outcomes? It'll vary. So for some people, the outcomes they want to attain with a smart building would be to improve the occupant experience or to create a high-tech wow factor for the tenants of my building. While for others, a smart building would be all about reducing the operational cost of a building by making energy efficiency improvements or improvements to how the building's workforce executes their day-to-day tasks, and maybe reduce the number of service trucks that roll or reduce the headcount of building operators that are necessary to keep the thing running smoothly. So there is no one definition, and that makes the rest of my conversation with you today a little difficult, but it also, as a backdrop, it's useful to know that you can collect together whatever features are available in the market to solve the particular problem. So the purpose of today is, what are some available features in the market that could attain the outcome of improved energy performance, therein getting closer to net zero or decarbonization or electrification. And so as I walk through a lot of the available features, the trends today, just keep in mind that there isn't a building out there in the world that implements every single thing I'm about to show you. It's finding the unique collection of available things to solve the specific problems that'll drive your business outcomes that matter at the end of the day. And that is how you can ultimately get the accountant to pay the bill for the thing you're trying to do, is if you can show real value in improving a business driver. In this graphic, just try to show that our attitude about a smart building is that it's this sort of underpinning technology that needs to touch or consider the entire continuum from the end user and the experiences through data that's enabled by software, which is part of a system, which rides on a building backbone. And ultimately, you have to even consider the context of how that building interacts with the site or the campus it sits on, and even all the way back to the city and beyond. And that could be city infrastructure. It could also be taken to talk about the grid that it's an endpoint on, or the water mains, or what have you. The building's not an island. It exists in an ecosystem. I mentioned that there's different outcomes that people can try to attain out of a smart building, and here's just a few of the ones that we see often. And really enabling net energy savings should be one of the things that we're going to drill in on today. Another bit of backdrop around where we're at in smart buildings today. This little pie chart is a visual representation of sort of the traditional method of designing commercial buildings. And at the outside edge, you've got the sort of design disciplines, and then all of the bits and pieces here, I'll put my mouse on the screen here. The next ring is, I know it's an eye chart, it's meant to be, that's by design. Just a few of the bits and pieces that those design disciplines have to tackle. And then further inside the ring here is a typical control system that discipline would often design to collect data out of those systems that they've designed. So for power systems, there might be some power meters and some circuit breakers that might gather data to an electrical power monitoring system. The elevators have a control system. Fire alarm has a system. Temperature controls collect together data commonly from mechanical and plumbing and sometimes fire pumps. We've got access control system, video surveillance, audiovisual, all these sort of systems which in the old way operate as a silo, different silos. What we like to do as foundational to any new smart building is to create a common converged network to collect together the data out of all these systems, and wherever possible to start, the goal ought to be bringing all that valuable data into a common core or a middleware layer, and to provide sort of single pane of glass user applications. And the user applications have to acknowledge the role of the user. So the security director at the building has a different set of needs from the chief engineer, which is very different from what the occupants of the building or tenants of the building may need to see. But done right, those user apps would be offer different surfaces or different interfaces for each of the stakeholders that have to care about the data. And this sort of represents, I guess, a variation on that, where there are small places where we still need a lighting control system, but we want that to feed through to the central core of the smart building system, or fire alarm may push data through. So one way that we as designers can try to accomplish a smart building is through the use of a Division 25 specification. And I may be preaching to the choir here. If you all belong to ASHRAE or you're coming to presentations, you know what Division 25 is. The CSI who carves out the different numbers and provides that Div 23 is for temperature controls and commercial buildings, has created a framework for Division 25. The challenge in Division 25 is that the master specs that many of the design firms rely upon to create the content that goes into new project designs or retrofit project designs, those master specs don't typically offer a Div 25 set of text to start from. So it leaves us designers to create that from scratch. And each design firm that has applied Division 25 has used it in slightly different ways. And you can sort of tell the heritage of the designer based on how they implement Div 25, whether they're rooted in the audiovisual world, rooted in the security world, rooted in the temperature control system world. But at the end of the day, we can use Div 25 to create a design for the layer that sits over top, or if you use this circle analogy, that sits in the middle of all these different end systems that are defined by the other design disciplines like mechanical, electrical, plumbing, some of the architects divisions. And so Div 25 is something that my firm uses quite a bit to accomplish these smart building goals in design. Certainly, if you're an owner operator and you're on the call listening to me today, you can go to a vendor and get a smart building solution applied without having to go through formal design that creates a Div 25 spec. But in the design world, and I imagine for many of the ASHRAE members, this is the construct we use to put these ideas out there in the market and collect bids from contractors. And just this quick sample that shows the number of different stakeholders in creating or constructing that smart building. It gets a bit more complex, and we add a few different bubbles to the chart here to get it done right. One that I will draw attention to is the idea of a master system integrator. That's maybe the contractor that would execute those Division 25 specs and provide a single converged or unified piece of software that could collect together all the different bits and pieces from the other building systems into a single user interface, a single pane of glass for those different building users that I mentioned. So let's get to the meat of today. I've gobbled up 20 minutes with background. I want to next take you through what we see are trends today in little features that are going into smart buildings. And I've broken this up into some chunks of related functionality. At the end of the day, we hope that all these are going to create better connected buildings with more actionable data and with better security. And with all these things, then we can create better energy outcomes or better operational cost outcomes for the buildings. So diving into foundations, I talk a lot about in my consulting practice about getting the plumbing right. And I don't mean the pipes that carry water. I mean the parts of a building that we're installing during the construction project that we want to last for 30 years maybe. And that could be the pipe, it could be the cabling, but the goal ought to be to provide the foundations that are hard to do once you've closed the walls up, to get that right during the project so that you can swap out endpoints, you can swap out software or network switches or controller hardware without necessarily having to rip open walls or tear down ceilings to accomplish an improvement. So the first foundational thing that's happening all over the place is the idea of converged data networks. In the past, we would have had, each of those subsystems that I showed you on the pie chart might provide their own network. And in a converged network, the owner, the landlord, the tenant would create a single network instance comprised of enterprise grade network switches, maybe a fiber backbone if it's a tall building, and all the traffic of all the things with network ports in that building would ride across that single converged network. That allows many of the better outcomes that I'll talk about later, where we might utilize a bit of data out of the lighting system to do something smarter with the air conditioning. Without that, solving some of the problems that require the interrelationships or the intercommunication of different siloed subsystems becomes impossible. So convergence is a core tenet to making things work more holistically or work together as one. Another foundation that most buildings today, whether it's retrofit or new construction, are providing methods for better connectivity for the users of that building, for the equipment in that building. And just a couple key pieces are distributed antenna systems so that no matter where you sit in the building, no matter where you walk, you don't drop a phone call. Also, whole building Wi-Fi, and getting Wi-Fi to all the corners, all the nooks and crannies of your building can benefit your workforce that has to run around and maintain things. In this picture, there's an operator on a tablet up on the roof. It can also benefit the availability to apply connected equipment. Maybe it's a new indoor air quality sensor that's got Wi-Fi connection, but if you don't have that fabric of Wi-Fi available, you couldn't deploy that possible solution. More and more every day, the equipment or the device manufacturers are embedding Ethernet network ports, IP communications in the tiniest little controllers or equipment that sits at the edge. So where 10 years ago, we might have expected that a big controller and a big panel in the mechanical room could be equipped with IP communications. Now we see IP communications in communicating coffee machines or, to every light fixture. Pictured in the top center there is electrochromic glass where the window tint can change, and the controller behind that has an IP port on it. The destination dispatch elevator kiosk in the lobby, IP port. So more and more, we're seeing Ethernet all the way out to those edge devices where just 10 years ago, it was more of a central thing. And that presents a huge opportunity for retrofit because you don't have necessarily the same cable plant installed. But if you put that fabric in today, we expect that that'll be valuable into the future. Coupled with pervasive Wi-Fi, you provided all the pipe that you would need to carry traffic from all these connected devices today and into the future. The availability of cloud software platforms has drastically increased the pace of new powerful features that we can apply to connected buildings. So while we have to solve the problem of communicating to the end equipment, to the chillers, the boilers, the light fixtures, the energy meters, the fact that we can go push that data out to a new vendor in the cloud who's an innovative new startup and brings a new solution set, that same old legacy data, and that those innovative software providers can develop quickly and deploy at massive scale without a huge investment in software developers, has really unlocked a whole new suite of features that are very cost effective. Many of them are available at the software as a service kind of subscription cost, so there may not even be a very big upfront capital spend to adopt some of these new software features. And underpinning all that is this, is it, whether it's Azure, whether it's Google Cloud or AWS, so much software horsepower is available with very low startup costs to the developers creating these solutions, that it's really, this has been taking the industry by storm. This eye chart is a little more difficult to talk through quickly, but I'll try to explain that this is a flattened out version of the pie chart that I showed 10 minutes ago. So the idea that in the old days, you had a bunch of siloed systems that did their own thing with their own front-end computer and maybe their own network. Because now we've got a converged network across the building, and because we're pushing all this data out to a single cloud platform, it's created a tech stack diagram that looks shorter and wider. So now the subsystem providers, whether that's an energy meter or a temperature control system or the elevator controls, they don't have to provide as much of that full stack. They provide the part up to, like, maybe it's a communicating card in their chiller. And then from there, the data gets handled by the converged network and passed out to the cloud. And so that this is another way of looking at that same shift in the architecture of the systems going into commercial office buildings. And we have to talk about security. It is a prerequisite. It's not a nice to have, it's a must have. And as we add more IP ports to edge equipment, that just increases the amount of risk that we're introducing. So if we don't get security right, everything's going to the cloud. If we don't get security right in the cloud, there is the potential that it all kind of crumbles if you get breached by a malicious hacker. So we need to get the security piece right. Next, we'll shift over to developments in available sensor technology. And this is a place where we can make a big impact on reaching net zero goals by better understanding how things are operating today, so we can better figure out how to improve their operation in the future. These sensors, because the manufacturers of these sensors in general are leveraging trickle down pieces and parts from the sort of the greater IT world, they're now able to embed Wi-Fi, embed powerful processors, embed Bluetooth into little edge devices for a couple $100, where before a similar amount of power and a similar amount of communication capability would have required a big controller in a panel with a network wire run to it. So that's sort of driving all of these current trends. So the first I'll mention is a range of new sensors in the market that are able to count people or measure where in space people sit. Some of them also offer software that'll illustrate that for you as a kind of a motion trail visualization, or maybe it's a heat map. They may present to you like a good, reliable count of people. And both of these offer opportunities to run the buildings more efficiently. So if we know that huge chunks of our open office space are not well utilized, we can decide to turn them off and to ask the workers who show up on a given day to consolidate themselves into one corner or one floor of the stack of floors, so that we can quit air conditioning or heating those unused spaces. If we understand how many people are in a space, we can right size the amount of ventilation air to the space and prevent wasted money on heating or cooling a large volume of outdoor air that's not being that's not required based on the number of people in the space today. The occupant portion of ventilation air is directly tied to the number of people. So This sensing technology is going to make big headway in our ability to efficiently run air conditioning systems. A new breed of lighting control systems are taking the kind of the world by storm. So rather than big central relay panels in the electrical closet, we're seeing more and more little edge devices that sit on every light fixture that let that light fixture communicate back wirelessly to a gateway or gateways around the building, so that each individual light fixture could be directly addressed. Maybe each light fixture even has its own occupancy sensor that you can use to really fine tune where that light goes. So if you've got one worker staying late in a big, expansive open office space, with more granular control of each light fixture or of each couple or three light fixtures, you could imagine that big chunks of that floor could go dark and save that wasted energy while that one employee works away at his desk finishing a presentation over in the corner. Another way to measure where people are in the space, which will help us to better right size or target the delivery of air conditioning, as well as potentially some lighting, is by furniture manufacturers that are including integral utilization sensors. It could be a motion sensor that's tucked underneath the desk. It could be a way that you log into the desk when you arrive. But if we know where the people are, we can deliver those services more intelligently. Metering is a fundamental these days, but it's always been a hard sell with building developers because metering costs a lot of money. So we see a reduction in the cost of metering. We see a new crop of small sub-meter type products coming to market that are going to allow us to measure further down the distribution chain. So where we always wanted to measure at the utility entrance, and we try to measure at each major user, like we try to measure electricity consumed by a chiller. Now we see it more and more feasible economically, and to actually measure down to maybe the distribution panel board with all the circuit breakers. And the same would go for other energy resources like thermal energy for the distribution of chilled water and hot water. There are some low-cost meters that let us actually measure that at every coil in an air handling unit, or at every branch that serves a different tenant takeoff from the building backbone main. Indoor air quality sensors may not have a direct impact at first glance on reaching net zero goals, but this new crop of low-cost wireless devices that can be deployed wherever you need to deploy them, and that can measure lots of different factors that contribute to overall air quality, are unlocking this new set of data. I guess I'd say is allowing us to figure out whether we might be overventilating the building or may not be ventilating enough. And marketing brochures that the IAQ vendors put out lately have focused a lot on making sure that the health and wellness of your occupants is addressed in a sort of post-pandemic or a pandemic world. But I do see an opportunity for these air quality sensors to help us right-size the amount of ventilation air that we apply in the future in understanding what we're doing today. Smart restrooms is an odd little niche that is becoming prevalent. There's two main end purposes of them. The first is to sort of understand how those expendables are being consumed. So are we running out of soap or paper towels? Do we need a new toilet paper roll? And that can make your custodial staff more efficient and not send them out to the restrooms until the restrooms have been used. But we also see smart plumbing fixtures that go into restrooms. It'll tell us how many toilet flushes have occurred, and that may help us to figure out where to target different bathroom retrofit projects to try to save water, to use our capital dollars more efficiently for the restrooms that are most commonly, they're used more, I guess, and maybe wait to replace the faucets and flushers until at the corners of the building that are unused until later in a project. Next big bucket is around data. That's a broad term, but data is what it would be like the constant in what a smart building is. Without data, it's we're nothing. So trends in how we access data, how we deploy data, are sort of fundamental, and there's been a lot of change in the last 5 years, last decade. The first would be that so many new technology solutions, whether it's the smart restroom solution, whether it's an energy meter, whether it's a giant BMS system from one of the big four BMS vendors, they're providing open APIs. And this is a new way to access the data that they have within their system that are, it's more easily adopted by the cloud software providers. So it's easier to make a selection to purchase a piece of equipment for your building and later purchase a cool little cloud application that optimizes that thing and expect that they can talk to each other. And it's fit for the web, it's fit for the cloud. It's an API is, we expect that it'll have baked in security considerations in ways that the networks we use inside buildings don't always address. Uh-oh. Oh dear. Can you hear me? Still, Rebecca, my presentation just
Yeah,
quit
I
on
can
me.
still hear you.
I'm sorry, my Microsoft products all seem to quit at one time. So
Oh dear.
it
What
should
slide
be,
number were you on by chance?
I was on, I couldn't tell you.
There.
Give me just a
I think
second.
I
I think I can get,
it.
I'm opening it again. This, maybe my company is pushing an update to Microsoft or something. I'm relaunching the presentation. I feel,
All
bear
right.
with me, everybody, for 1 second. I'm very sorry about this. It's embarrassing when a technology guy presenting to you has a technology problem.
It
Rebecca,
happens to all of us.
if you've
Yes,
got
I
it
do.
available, I might ask you to share because it tells me it's updating Office right now. What a time.
Okay. Yeah, let me get this open. Give me 1 second to switch it over.
Okay.
Um,
I don't know why
okay.
12:40 p.m. on a workday seems like the right time to update Office, but
It tends to be how it is sometimes.
all right.
All right. Let me know if
Thank
you're
you.
able to see that. All right.
I do. Yeah. Could you advance, please?
Yes, please. There we go.
I'll just ask you to keep advancing as we go.
Yeah. Give me 1 second. There we go. Okay.
Very good. Okay, thanks. Another trend that's pushing the adoption of kind of this modern architecture of converged networks that feed up to the cloud is the idea of an independent data layer, or sometimes called middleware. There's actually a new software as a service offering that handles the middleware piece on a sort of subscription basis. That means that you've outsourced the hard part about speaking different protocols from the chiller to the cloud, or from the lighting control system to the cloud. There have been products in the market that solve for this for a number of years, but it's really, it's almost becoming commoditized, and that we think will drive an even more rapid adoption of modern architectures of cloud applications. So next slide, please. This is an odd one, and I could talk for a whole hour about this topic on a different presentation, but we're seeing the industry adopt the idea, quickly adopt the idea of that we need to apply metadata about the data we're collecting. So it's one thing to pull in 57 temperatures out of a building management system, or to pull in 42 light levels out of the lighting control system. But along with that, we also need to model where does that data come from? What is it connected to? And if we can apply metadata, that which literally means data that defines or describes data, if we can apply context to what that data is, now we can create digital models of a building. We can create algorithms that automatically can comb through a mountain of data and find new insights, which in the old way, where you had a point in a system and you applied a name to the point and you organized it in a set of folders based on which floor of the building it sat on, but the data itself, the data model didn't know where the service came from. We couldn't really apply that power at scale in the way that we can when we apply either like the brick schema, which describes the relationships among equipment. For anybody on the call who's a consultant and works in Revit all the time, this is the idea that we're containing the same sort of relational data about the service of equipment, from air handler to VAV, or by from switchgear to distribution board to circuit breaker to outlet, so that we can then write algorithms that come through it. Project Haystack's another place that applies a set of tags to do the same thing. Could you go to the next slide, please? The next big bucket is around certifications. This will go quickly. There are two smart building certification methods that are products that are available in the market today, that I hope in the same way that LEED and then Fitwell and Well Building and Green Globes have pushed a lot of building owners to make investments because they want to put a plaque on the wall, because the market demands that plaque on the wall. It's caused owners to make smarter decisions around sustainability, around materials selection. We hope that these certifications will do the same for building technologies. So next slide, please. The first I'll talk about is SmartScore. That's a new certification run by a company called WiredScore, and it attempts to break down the features of a building and their ability to deliver user functionality in 6 big buckets, and sustainability is one of those 6 big buckets. Next slide, please. The competitor, I guess, is called Spire, and this was conceived by a collaboration between Telecommunications Industry Alliance, I think is TIA, and Underwriters Labs. And similar outcomes that they get to, they score you based on your ability to meet several kind of point scoring rules, and at the end of the day, you get a plaque on the wall if you comply. And like I said, I hope that that this will cause building owners and developers to apply more intelligence, because maybe the market will be demanding that, they'll be shopping for real estate in buildings that are Spire certified or SmartScore certified. Next slide, please. Next big bucket I'll move kind of quickly through, but this is in how the smart solutions come to market. This is very valuable to owners, but maybe not so much for consulting engineers. But could you go to the next slide? The first is the idea of a master system integrator. This is a relatively new type of contractor that typically is an outgrowth from a normal temperature control contractor. Maybe think, one of the big branch offices of the big 4 firms, but a master system integrator has developed skills, has hired people, and invested in software that position them to do more integrating of multiple systems from different vendors, of building enterprise grade Ethernet networks that are secure and with managed firewalls. So a master system integrator is typically unaffiliated with any particular control brand, but instead are really good at dealing with all the brands, at dealing with different protocols and different, especially now that we talk about cloud platforms, there's a new set of protocols that the normal temperature control guys in the world may not be up to speed on, but the MSIs have invested their training dollars in understanding how to use MQTT to share data out to a new cloud application. Next slide, please. Just like the MSI is not typically affiliated with any particular brand, we like to specify where possible kind of open market products. And that's the idea that rather than a single vendor that controls all the bits of a solution from top to bottom, then you're stuck having to call on that single vendor to replace something in 6 years when it breaks, or to sell you an annual service agreement to keep it repaired. Open market products would be something we describe as available over the counter without any territorial restriction on who can sell it. You could buy it through distribution rather than through the branch office. And we think that for most buildings, this yields cost savings over time, lets you find solution providers or service contractors who are best attuned to your needs, hitting the right price point and all that. Next slide, please. Finally, apps, and I think I'm doing okay on time. I've got 4 minutes to speed through this. So all the stuff that I talked about to now gets us to the software we can apply over top in the cloud usually to really influence better outcomes. So next slide, please. Fundamental to making buildings operate more efficiently is some kind of energy analytics or optimization software. And there's a lot to pick from in the market today. And I'm not here to recommend any particular one, but there are, and they span the range of kind of cost of a price point, cost of entry, power, features. Some of them might integrate with the BIM, with your Revit model. Some of them might be called digital twins. Some of them might be offer like augmented reality features. But at the end of the day, we've got all this data coming from all these sensors across a converged backbone. We've got secure data that's been brought into middleware and shared into the cloud. But what we do with it is understand how the things are operating, look for anomalies, look for new insights in ways that we can save energy, just generally make things. So this would be the number one category here for going after energy savings from a smart building. The next slide, please. An outgrowth of energy analytics is a unique application called monitoring-based commissioning. Monitoring-based commissioning is really a service. It's a process. It's not a piece of software, but monitoring-based commissioning companies that offer this process, this service, lean on software that culls through all the data being spit out by all the things in your building, from the elevators to the lights to the air conditioning, and looks for things that are going out of normal, things that are slipping from the way it should perform. We all know that building commissioning or retro commissioning is kind of an activity that happens one time, and you tune everything up and you get the building running as designed, as intended, or maybe better than, maybe improved beyond what the original design envisioned. But then the commissioning agent goes away and the performance of the system starts to slip the very next day. Operators put things in override, equipment breaks, actuators slip on the shaft, all kinds of things start to happen. And monitoring-based commissioning as a process seeks to look for things that start to slide and draw attention, get those things fixed, get those overrides removed, and keep the building running as commissioned every day of the year. Next slide, please. AI and ML is an emerging set of features that different software solution providers can now apply more easily because they've got their solution built in the cloud. And Microsoft, Amazon, and Google, Salesforce, everybody, all the cloud providers offer engines to let you pretty quickly apply powerful new algorithms in ways that a BMS developer couldn't have imagined not 5 years ago. And so this is going to really influence the ability to keep things running more efficiently. It'll improve the quality of energy analytics, of optimization routines that we can apply to buildings. Next slide, please. And I promise, Rebecca, I just have, I think, 3 more of these, and then we'll get to questions. Portfolio management. If you operate a campus or an enterprise portfolio of buildings, a portfolio management application can help you take stock of the entire fleet of buildings that you're in charge of and start looking for buildings that are outliers. Why does this one out of my chain of 42 fast food restaurants, why does this one consume so much more energy? What are they doing wrong? Or where can I invest my retrofit dollars to improve the worst performing among my portfolio? Next slide, please. Tenant Experience is probably the least impactful to building energy spend, but it's, I think, more and more commercial office landlords are investing because they feel they need to keep up with the Joneses, and they're applying some kind of an app that the occupants of their building can launch to get to book a conference room or order delivery food from the cafe in the basement, to book in a parking spot. And there are opportunities for improved performance if the app utilization can help figure out like what's their preferred temperature or whether they're in or out of the building. We could imagine some improved energy outcomes as a consequence. And next slide. I'll skip past this one to the next slide, please. I think it's my last one, is digital twin. Kind of mentioned this before, but a digital twin is like an energy analytic platform, maybe, that where all the data, along with its relationship metadata, which I talked about before, can be applied. It's a little different in its character from a normal like energy analytics platform, in that because the geometry of the building is modeled, the building physics are modeled, a digital twin makes it more easy to create accurate building energy models, maybe that inform the optimization algorithm that can make your chiller plant run more efficiently. It's kind of like the most sort of like the powerful intersection of energy analytics with building information modeling with the features of an energy analytic platform. And once you've got all this constructed in a digital twin, now it might become more cost effective to apply artificial intelligence or machine learning to solve problems that have been impossible to solve with software before. I'll leave it at that. Next slide, please. That's me, Rob Knight, and I'll take any questions if any have come. I don't see any in the question and answer pane, but perhaps they show up privately.
Just give me one moment here. Got to coordinate a few things on my end. Appreciate all the patience, everyone. I am not seeing any that came in at the moment. If anyone has any, remember there's that Q&A box at the bottom of the screen, so you can go ahead and type in your question, and we can get them answered live for you.
I'll use this little pause in the action to once again apologize for my technology meltdown, but Rebecca, thank you for the save.
Not a problem. Yeah, I'll give them a few minutes here. While we're waiting, thank you, Rob. It was a great presentation.
Well, I know I moved rapidly through just a number of kind of sort of superficial in a lot of ways, what's out there and available today without a deep dive into like a single application to trend towards net zero. And I hope that everybody on the call today was, came in expecting this sort of a overview and not necessarily a deep dive into a particular solution set.
Yeah, no questions as of yet. Well, let's see. Give it one more minute, just in case anyone's in the middle of typing something particularly long. All right. Yeah, I'm not seeing any coming in. So let's say we're good to go.
I guess
thank you so much,
them
Rob.
all.
It was a very informative presentation. Thank you so much. Remember, everyone, we got a couple. Oh, sorry, go ahead.
I was just going to thank all the audience for sticking with me through this hour, and have a good St. Patrick's Day.
Happy St. Patrick's Day, everyone. Yeah, there's another 2 webinars on the 2nd and the 24th, if anyone's interested. Those will also be at noon. Thank you, everyone, for attending. Thank you, Rob. It was a very good presentation. We'll be shutting it down now.